Hello student, I am Arnab Das. Today we discuss about the convolution code. As we know that error control code classified into the two category form. One is the block code and second one is named as a convolution code. Last few lecture already we discussed about the block code, and that one is defined by the n comma of k, where n is defined the how many number of bit you have to use for code word, and k is defined the message length in a bit form. That is, k message bit is encoded into an n bit code vector form for block code. Now for the nkm, for the convolution code, which is represented as such, where n is defined how many number of output channel you have to use or line you have to use. K is defined how many number of input you have to use or input line you have to use, and M is defined how many number of memory elements should be used on there for that kind of convolution code. So for the convolution code, there an memory element will be present. That is, the present output is not directly depend only on the instantaneous value of the input with also the previous data of output. But in the block code, there no memory element is present. That means there the output is totally depend on the instantaneous value of the input one on there. For convolution code, so if you just read out this text, output of a convolution encoder not only depend on the present input but also on the previous input, where n is the number of output line, as I told, k is the number of input line, and m is the number of memory element. This is defined by the form of n, k, m as a comma. Before going to the convolution code, there's some term you should be know about that. And first one is the code rate. What do you mean by the code rate? Code rate is defined as the ratio of the number of input line to that of the output line. That means how many number of input line you have to choose, which is defined by the k, and how many number of output line you have to choose. If you ratio between them, that is k by of n, will be defined the code rate. If we consider the message length is L, that time the convolution encoder will be length as a n into L plus of m. In that case, the convolution code, for the convolution code rate will be as a form of this one, that is k into L. Capital L is the length of the message by of n into L plus of n, that is the encoder length. If you ratio between them, that time you can got it the code rate. Most of cases L is very greater than the value of m. If it is, that time you can omit the term at the position of this, that is L plus of m can be considered as only of L. So the modified expression can be as a KL by of NL. That means in this case also we can say that R, that is the code rate, will be defined as a form of K by of N. So this is an important term for the convolution code. You should be remember this one. Another one term, this is defined as a constant length, which is defined for a single bit, of input, how many number of encoder output can generate. That means if you just read out this text form, it is defined as a maximum number of output bit of the encoder affected by the single input. That means their message length L is equal to given to you as a value of 1. So what will be the encoder length then? N is equal to formula is as a n is equal to L plus of m. So if the value is L for the 1, then n into 1 plus of m will be defined the total bit change or effect due to the for the single input, and this is defined the constant length, and which is n into l m plus of 1. So this is n into of m plus of 1 will be defined the constant length for the convolution code. Now by using an example, it will be easy for understand for the convolution code. So we just go that one. Let me take an example. Question is that obtain the output of 2 comma 1 comma 2 convolution encoder for the input this one. Which one you have to indicate the input line, which one is the output line. First one is defined for the n, so this is output terminal will be there 2. Look at the figure also given the two output terminal, one is the V1 and another one is the V2. Middle is defined for the k, that is the input line. How many input line will be there? One. Look at here, single input line is provided on there. And the last one is defined for the small m, and that is defined for the how many number of memory element you should be used on there. So in this case 2, so there are two memory element is present, that is m1 and m2. So this is can be a encoder diagram for the 2 comma 1 comma of 2 convolution encoder. Now the question is that what will be the encoder or encoded data for the input of 11101. For this data you have to identify this one. That means the what should be in the serial form, what will be the input one on that case, this will be 10111. By using the simple analogy, I think it will be easy for understand. By using an calculator, if you want to write down the number as I say 45392, so which one number you should be type at the calculator or the computer as a screen, this will be the 4. So the MSB bit you should be write down first, and LSB bit you should be write down the most cases. Okay, so here also look that the same thing is happened. This one is first write down in this position, and then the second MSB bit will be written as a LSB position in this way. Last one is due to the reason of this one. So here LSB is used in this case MSB, and MSB is used in this case as a LSB. Now we are interested to identify what will be the encoder length. Encoded output, what will be the output length? The formula was as a n into of L plus of M. So already you know the value for the n, and n is there 2, and M is the value of 2 also. So L is the value, how many number of bit is used there? 11101. That means this is the 5 is there for the L. So the value will be 2 into 5 plus of 2. That means the total result will be 14. So for the encoder output, the 14 bits of data will be used for the input value of this one. Okay, so we have to identify what will be the 14 data at the encoder side as output. To do this one, you have to check initially for the V1. This is the result for the instantaneous value of the input, that is defined as a P also, and the previous value of the M1, that is the SR1, this is defined by the P2, and also this is the mod addition of previous data of M2, that is defined by the P3. So for the V1 you can say that this is P1 you should be active, P2 should be active, and P3. P1 is the instantaneous value, P2 is the previous value of M1, and P3 is the previous value of M2. And if we check for the V2, that time this is depend on P1 and P2. This is P1 and P2. So P1 is the instantaneous value for the V2, then P1 will be the instantaneous value and the previous value of M2. These two, if you do the mod to addition or operation, that time you can got it the value of V2 on there. So you just check this one. Look that v1 is the defined v1 is defined the value of the instantaneous one value with also the m1 m2 previous value. So if you want to get the value of this position, that means the instantaneous value is 1 and previous value for the m1 is 0 and m2 is also 0. So for this two 0, 1 plus 0 plus of 0, that means the result will be 1 on there. If you consider for this line as you say, so here instantaneous value is this one and the previous values are these two. So for the m1 is the 1 and m2 is the 1 also. So the result will be 1 plus of 1 plus of 1. The ultimate result will be 1 on there. Okay. Same way, if you consider for this case that it will be 1 and here the previous value is the 0 and 1. So result will be 1 plus 0 plus of 1. That means it will be 0. Here for the v2, v2 will be defined as a value of the instantaneous one. As you see, we are considering this section instantaneous one and the m2 previous value. So this one m2 previous value. So this is 1 plus 0. The result will be this will be just a minute. This will be 1 plus 0. The result will be 1. So this one is the 1 on there. Okay. If you consider this one, the instantaneous value is 0 and here the previous value of for the m2 is 1. So 0 plus of 1 is again 1 on there. Okay. So this is the way by which you can got the value of v1 and v2 value. Now the question is that how can you got the value for the m1 and m2, and then if you got the value of m1 m2, then you can got it the value of v1 and v2 also. So to do this one, look that the figure m1 for the p1, this is directly connect with the value of the u, that is the instantaneous value. So instantaneous value for the m1 is defined the p1 and the previous value is defined as a p2. So from m2 also this is defined the previous value of m2. So you just follow this one to do that particular or write down the table. So to get the value of m1 for the, as you say, this condition, instantaneous value will become for the m1 and for the m2 it will be the m1 previous value. So this will be defined the 0. So here that value will be 0. If you consider this one line, so here instantaneous value is 0, so you just write down here 0 for the m1 and m1 previous value is the 1, so that one will be write down in this position. So for that particular instant, that m1 sorry m2 value will be 1 on there. Okay. Now check the same way in this line. Check for this line. So here instantaneous value is the 0, so it is m1 also with the 0. Previous value of for the m1 is the 1, so you just write down 1 for the m2 position. So in this way you can build the m1 m2 what will be. If you check on there, there u is the maximum value is defined for the u, it is maximum value is defined as a 5. Look that their input signal is given as a form of the 5-bit data, that is 11101. But when you make the table, that time the total element you are choosing as a 111, yes, that is the extra 2 is added on there, and this is reason for that there are two memory element you use on there, and for this reason 2 extra bit you should be used on there for the input side, and that one will be obviously as a value of 00. That means for 2-bit position, another 2 extra bit position, you don't use any kind of data, and that one should be as a 0. If anywhere the question is given that this is 2 comma 3 comma 4, that means 2 is defined, that is 2 is defined the let again I just write down 2 3 and 4. So 2 is defined how many number of output line, 3 is defined the how many number of input line, 4 is defined the memory element. So there extra 4 bit you should be used as a input for representing the ultimate encoded code. Okay. So that but extra 4 digit you should be apply as a 0 on there. In this case, due to the reason of m is equal to 2, the reason of that m is equal to 2, it is applied at 2 times as input 0. So this is the full table by which you can able to identify the um, diagram also, and what is the form on there. Now the what is the way by which you have to do that particular code word. To do that code word, you have to write down one after one as a form of v1 v2. For the first one, you have to write down the code word as a 1 1. For the second one, you have to apply as a 0 1. For the v1 is 0 and v2 is 1 on there. For the one again, the third one, it is the 1 0. In this way, the pattern will be write down on there. So the sequence will become at the encoder side for the 2 comma 1 comma 2, this encoder, the result will be this is 1 1 0 0. If we check on that last, this is 1 1, look that this is 1 1 is present. For the 1 0, this is 1 0 is present. For the 0 0, this is 0 0 is present. So this is the encoded output will become for the transmitter side encoder 1. Okay, and if you count the number of digit is used or bit is used as a 14, and that one is already calculated by you, and the formula was as a n into of l plus of m. So here n was 2, l was 5, and m was 2. So this is 14, and look that here counting also come as a 14 bit data. So if there any problem, then obviously you can ask. Otherwise, I think each and everyone able to learn how and which way the encoded bit you have to generate by the convolution process or for the convolution code generation. If the any circuit or block diagram is given to you, so next day we come again with another new one topic, and till I have to say have a good day and bye.